Because of its special characteristics, titanium is used in a wide variety of industries. Its strength is roughly the same as that of conventional steel, however it weighs 45% less. If you compare titanium with aluminium, the former is 60% heavier and about 50% stronger. In the chemical industry, it's used to manufacture chemical reactors, pipelines, pumps, and reinforcement. In the military industry, it's used to manufacture flak jackets, fire partitions, and submarine hulls. Titanium is also in demand in the automotive, agricultural, and food industries. It's used to make sports goods, jewelry, and mobile phone parts. Like any other metal, before titanium is ready for production, it is processed. To forge titanium, first it is kept at a temperature of 650 to 700 degrees Celsius. It's heated up to a temperature of 900 to 1600 degrees just before the forging process. The purer the titanium, the lower the temperature of its forging. The heated piece is pressed to destroy the coarse-grained structure and get rid of voids. Interestingly, the hammer is also heated before forging to about 200 to 220 degrees Celsius. This is necessary to keep the metal warm and reduce the changes in temperature. The temperature range of iron forging varies from 800 to 1250 degrees Celsius. Factories and production facilities use incredibly powerful equipment to process this metal, usually because the pieces weigh dozens of tons. The video shows the forging of a 35-ton metal block. To forge this giant piece of metal, workers use a piece of equipment with a force of 14 meganewtons. To move the metal through the production floor, a special manipulator is used. The maximum capacity of this particular piece of equipment is 50 tons. Special steam hammers are used to process smaller and lighter workpieces. Interestingly, it's one of the oldest pieces of forging equipment. It's been used since the early 1940s. A steam hammer is a hybrid between a piston and a steam machine. Previously, when a blacksmith turned the handle, the steam that came out of the boiler forced the firing pin upwards. When the blacksmith turned the handle in the other direction, the steam supply stopped. The falling piece, under the influence of its own weight, hits the workpiece with a force impossible to achieve with a hammer. Of course, the appearance of the equipment has changed a lot since then, but the principle of operation has remained the same. You have to use 9 steam hammers to process a workpiece weighing up to 2,500 kilograms. Their weight varies from 300 to 6,000 kilograms. In spite of the fact that modern technologies have gone far ahead, manual forging is used for especially small pieces. Engineers around the world continue to develop equipment that will enable them to produce high-quality metal parts in a shorter time. The video shows a forging press produced by the Japanese company Mitsubishi. It's a system of machines that perform forging and auxiliary operations, such as transporting the workpiece from the warehouse to the presses and rolls, edging, packing, and so on. First, the workpiece is placed in the soaking pit, where it's heated evenly. A special conveyor belt then delivers the hot metal to the press. The mentioned equipment creates a pressure of 3,000 tons per square meter. Note how the metal decreases in size under the influence of such a huge force. This is how the metal is pressed, filling the core blows and voids that were inside. During the cobbling process, scale forms on the metal surface. You can see how it crumbles. It's noteworthy that the cross-section ratio of the finished product in relation to the ratio of the original piece is 6 to 10. The ratio changes to a 3 to 4 ratio if a particularly dense casting is performed. Forging is a method of metal pressing that can be done in two different ways. You can see one of them on the screen right now. It's called stamping. The workpiece heated to the forging temperature is shaped with a special metalworking machine tool known as a stamping press. The flow of metal is limited to the surface of the cavities and protrusions produced by the die. This method is used when it's necessary to obtain a large number of pieces of complex shapes. What you see on the screen is the method of open forging, which is essentially the opposite of stamping. Here, metal is not placed in a special form, nor enclosed from the sides. While the workpiece is shaped, it's not enclosed in space at all. It can be, but only from one side. Open forging, in turn, can be performed manually or automatically. The first one, as the name suggests, is done by hand by specially trained specialists. This method is used when it's necessary to perform a single production of small forgings or repair work. The foreman uses hand hammers, sledgehammers, chisels, and other tools. The automatic method is perfect to make large forgings. All the videos that we've shown you today, including the one that's being shown right now, are examples of automatic forging. As you already know, it's carried out with the help of hydraulic presses of more than 15 tons of power. Here we show the creation of complex forgings without the use of manual tools. First, the blank is squeezed until it becomes thin and wide. Then an iron hollow rod is lowered into the middle, forming a hole. Then the final cobbling is done, during which the workpiece is shaped as needed for production. It's noteworthy that during this process, cold water is continuously circulating inside the rod. This measure is necessary to ensure that the rod is not heated and compressed along with the workpiece. In order to expand the size of the resulting piece, the metal is subjected to a special semi-cylindrical roller. When the piece is ready, the special pliers move it first to the conveyor belt and then to the storage room, along with the rest of the finished products. Working at plants involved in metal processing is extremely dangerous. Workpieces are heated to extremely high temperatures, so the more machines that are involved, the better. Fortunately today, most of the modern factories minimize the work of people. Only occasionally people have to be near the hot metal. All the main work is done by the operators from afar. Surprisingly, a few decades ago, metal processing on such a scale was simply impossible. The metal piece you see on the screen weighs at least 120 tons. And of course, only the most technologically advanced and powerful equipment can move and process it. Hey, stop being lazy, it's time to use that brain of yours. Welcome to Brain Time. Incredible facts from the past, the present, and even the future. The power of nature and wild animals, amazing facts and unsolved mysteries. You'll find all this and much more here. Subscribe now, you won't regret it.